The Bohr model versus the quantum model. It's quite the comparison. People were asking everywhere, what does the hydrogen atom spectrum look like? They were practically begging for answers when finally they got one in 1913 from Danish physicist Niels Bohr. According to Bohr's model, the electron can circle the nucleus only in allowed paths, called orbits. When electrons orbit on the energy level closest to the nucleus, it is in its lowest energy state. Remember, electrons cannot exist between orbitals. So how do they change energy states? Well, since you asked, when an electron falls to a lower energy level, a photon is emitted in a process called emission. When an electron jumps to a higher energy level, a photon is absorbed. Oh no! His model could not explain the thousands of atoms existing with more than one electron, nor did it explain the chemical behaviors of atoms. But wait! Help is on the way. The quantum theory describes the model in a mathematical sense, based on probability. Why was Bohr's model incorrect, you ask? According to the quantum theory, it's impossible to know the exact position and momentum of an electron at the same time. Quantum numbers specify the properties of atomic orbitals and the properties of electrons in orbitals. The first quantum number is the principal quantum number, which indicates the main energy level occupied by the electron. The second is the angular quantum number, which indicates the shape of the orbital. The third is the magnetic quantum number, which indicates the orientation of an orbital around the nucleus. And the fourth is the spin quantum number, which indicates the two fundamental spin states of an electron in an orbital. Bam! Mind explosion! This presentation was made by Amy Ellsworth, created by Powtoon.com. Thank you for your time.
Created using Powtoon.